Hey, Mike. How's it going?
It's going pretty well. How are you, Dan?
I am doing pretty good. I was uh, disappointed Chris couldn't join today, not because I didn't want to live stream with you, of course, but because I actually um, have my mirrorless camera up, and so I look as official as you and Chris usually do now. Um, but he'll have to wait until next time to
I do
appreciate.
not look official. Chris makes fun of my camera all the time. I'm
Well,
using like a Amazon special Logitech webcam.
maybe Chris is just mean. I feel like that's what I'm learning here because I think you look pretty good.
Yeah, he has a fancy camera. I'm not jealous of it because I don't really want that in my workspace, but he has that teleprompter set up. So
Oh,
his camera is behind an angled one-way mirror. Is that
oh,
what they call
right,
them?
yeah, uh-huh,
And so he can see he can look right at you, and the camera's also looking where he's looking, which is pretty cool.
yeah, that is very cool. Yeah, most of the time I feel like I'm on camera. I am not actually reading off anything, which is either a comment on my preparation or a comment on my typical live stream scenario. So, but I guess he can. Well, it's not in front of his computer, so he'd be looking up at it. Well, yeah, I guess that works pretty well for his videos. But anyway, I have a non-work project that required me to have the camera set up, so I thought I'd just keep it going. But I have the autofocus turned off because it just really struggles with like going in and out of focus, and yeah, honestly,
Yeah.
it's like terrible to watch. Um, but I also am having trouble like getting it focused and then like staying still because the range is very small on this lens. So anyway, seems close
It's
enough though.
hard to be a celebrity streamer, Dan.
Oh, it's so hard, you know me. All
You know that
67
the
of my
other
YouTube subscribers are
yeah.
clamoring for more. So
With Chris, he has that, I don't know if it's a shotgun mic or whatever, but he's got a mic that it points right at him, and so if he moves a little bit off axis, he gets really quiet.
yeah,
He doesn't
I
want to
will.
have the cool looking mic in the shot, I guess.
Yeah, that's okay. So I mean like his setup is very official. No one would debate that. But I think the mic looks cool. I like having the mic in the shot. I mean, I know it's like more professional for it to be off camera and for you to still sound amazing, but uh yeah.
I just want something that's easy. So, like I've got mine on a swing arm and I just put it right here when I need it and I put it somewhere else when I don't. And I don't really
Yeah.
have to worry about being in the right place or this or that. And
Yeah.
um,
Well, here's a
yeah,
question. Oh, actually go ahead.
no, he convinced me to get a down camera, and that does not have autofocus on it. And I find it troubling. I mean, for like
Mhm.
demos, it's fine, but um, it's challenged. Like autofocus is a nice thing.
Yeah, for sure. Have you so the holidays are coming up here. A time when people travel, including people like you and me. But I'm curious, have you ever traveled with your I guess you typically don't do streaming, but you do a fair amount of like video recording, right?
Mhm.
Have you ever traveled with your audio and video setup?
I did a lot when I worked at Hackaday. So
Mm,
we'd go to different conferences and events and that sort of thing. And so I would just take this mic with a tripod
mhm.
for podcast recording, and then like often I had a like compact travel tripod, and
Okay.
I could set it up at a convention, and it had a hook. Like it was super lightweight, which is a problem because if someone like bumped into it, it would, your good camera would be gone.
Right.
But they had a hook. I could hang my heavy backpack on it, and that would like weigh it down, like underneath the tripod part of it.
Yeah.
And then I would be able to be like a one person video interview shop, which is great. I had like a wireless microphone and DSLR, and it was all going. The problem is when you got a million people around and you got the tripod set up there and you're trying to, people just walk right in front of the camera. Like,
Oh, that's fair.
I
Yeah.
mean, what I expect them to do is like, it's not my like private space to be setting this stuff up, but it just made it a real challenge for some of those interviews. But stuff like Chris turned me on to the international manufacturing. Sorry, there's a dog in the background.
No, that's great.
IMTS, the International Manufacturing Trade Show,
Okay.
and they had like all these crazy like laser sintering, like printing in metal using lasers to sinter the metal powder onto the things that you were additive manufacturing and all these milling devices and stuff. So I ended up getting a ton of cool demos there because of this travel kit that I
Oh,
had.
that is cool. Yeah. Yeah, I wanna do more, well, I guess I am doing more, audio and video things. I'll just say that ominously because I haven't put anything out there, but I have I'm building a back catalog, if you will. Um, but yeah, I'm always super impressed with folks that travel around. I don't think the traveling and like interviewing folks or getting videos of demos and that sort of thing. I don't think I'm able to do it. Excuse me. I don't think I'm able to like do it regularly. It's too much for me to like be going around. So, but there are so many good online tools now, so that's helpful. But anyway, what have you been up to this week?
Mostly we are overhauling our docks and to make them kind of like organized in a way that is more accessible. I think like the information that you are looking for will be where you're looking for it. And so I'm excited about that, except for uh, I went and checked on the links that were broken in this move, and we had 562 links that have changed places. And so I've gone down a rabbit hole of 301 redirects through Firebase on trying to get these all. The good news is like I don't think it's going to be a problem. I'm down to like 40 something that I need to sort out, and I think I can still. I think many of those are like multiple wildcards. I'll probably get down to have like 2 dozen that are going to be like 1-to-1 redirects, but that is not as automatic as I would have thought redirects would be. You would think you could be like, hey, figure this out for me, but there isn't like a piece of software for that.
Yeah, I have never enjoyed working. I mean, like there's the aspect of this that's like strictly functional, right? Like getting all of um the redirects in place if someone directly navigates to a link, and then there's the aspect of the SEO portion of it, which I know we've chatted about a little bit. And I have never enjoyed working with anything related to SEO because it just feels like it's one of those things where I don't want to know too much about it, like it feels like a manufactured I guess a lot of systems are human made, right? But it feels like a manufactured system that like is made to be gamed, and it makes me very uncomfortable in working with it. But I feel like you've done the proper amount of research and
Yeah.
have like a good we talked I know about when we were talking about this a few different like options for preserving old documentation versus redirecting, et cetera, delisting things from search engines and that sort of thing. And I feel like you were able to do the research and come up with a pretty pragmatic option of saying like, oh, we don't actually want the old docs there. We want people to be using the new stuff, and we can redirect them
Yeah.
appropriately.
Well, we're not really like removing anything. So I think if you are versioning your docs, it's because the stuff that people used before isn't there. And we're
Mm-hmm.
not doing that as much as we are like just changing the organization of it. But I know what you mean with that like SEO, like there's some like shady undercurrent of like, haha, I can game the system and get you on the front page of whatever search engine. Like we've never done that. Like we don't do that at Goliath, but we have pretty good search placement just because we try to publish content that is useful to people in areas that people are searching for, like especially over the air updates and IoT and Zephyr and stuff like that. So we don't want to mess that up. So if all of a sudden those pages are just 404, then I think you'll drop off, and we don't want to do that. So the 301 is it tells the search engines, hey, just update your link to point to this page instead. And when it gets there, I don't know how much like a Google would compare the old page to the new page, but they should match pretty exactly. So I don't think it'll look like we're gaming the system or anything. We're just updating our site. So it should be pretty easy, except for it's not that easy.
Yeah, right.
I ended up doing, I'm using the sitemaps. So we use DocuSource for our docs. and it'll generate a sitemap with every link in an XML file. So I'm taking like the live site XML file and the development server XML file and then comparing the two. And then I had to write a script to interpret the weird Firebase syntax, which they use globs, which I may have heard of globs at some point, but it's mostly like some Unix like file system hierarchy thing. And then I don't think their globs are like, I don't know, RFC adherent or whatever it is. So they have wildcards that are like colon and then a word, and then you can have a star at the end or not have a star at the end. And then that'll just, and like, I looked around and I'm like, I must be able to find a library that does a regex with this, right? And I like couldn't. And I'm like, well, I must be able to find a glob library that'll be able to process this. I'm like, I couldn't. Then I was like slicing by forward slashes because I'm like, it's URLs. It shouldn't be hard to slice by forward slashes, except for one of the wildcards that Firebase uses has a forward slash in it. And it just, it's been a thing.
Yeah. I feel like typically when I've had to interact with platforms that are doing any sort of like routing or, any sort of like static site hosting, you can figure out what language they're using on the back end by their like public API for routing, because you're like, oh, what's the standard library implementation of, like for instance, globs. It's very easy to tell when people are using Go because it has built-in support for that. And so actually, I think even some of the regex sites will have like Go style glob pattern matching kind of stuff. So anyway, I always think it's fun to be like, oh, I know what y'all are doing behind the scenes there.
Tricky. What have you been working on this week?
Let's see. I feel like there was a mix of things. So I have been doing a lot of front end work, which is not the typical thing you hear from me. But it's been out of a necessity, maybe rather than a optimal allocation situation. But yeah, so we've done some rearranging, and maybe we'll pull up the console later of kind of how our console is laid out. Mostly from like a layout wrapping perspective. So in the past, you've done things in the context of projects, and projects could exist under your personal account or under an organization. The closest parallel I could think of for folks to relate it to would be like GitHub. You can have repositories under your personal account or repositories under an organization. And I think for the GitHub model, that makes a lot of sense, especially when you have public repositories where you may have, personal work or solo projects or things like that. And certainly you could have solo projects on Golioth as well, right? You could be doing, home automation or whatever.
You should have solo projects on Golioth.
Absolutely. But one of the things that solo projects can, or the projects under your personal account can be difficult is if you want to then move that to an organization or you grow it, you're doing prototyping and that sort of thing. So we're basically modeling everything under an organization now, and you can still have a personal organization, but you can kind of control the upgrade path of things a little bit easier. So rather than, paying for your personal account, you could have multiple different organizations at different tiers based on what you're trying to do there. So essentially now everyone starts out with a personal organization, and they can create projects within that. And if they want to grow that into, an organization that other folks are a member of, the path to do so is very straightforward. But if they want to keep that their personal one, and then they have a business one or something like that, they're able to do that. So basically now, because all projects exist in the context of an organization, in our navigation, you'll always see at the top the org name and then the project name, and then, whatever page you're on if you're doing device management or something like that. So I've been working on that, which has been fun. And then also some more secretive backend things that we'll talk about next year.
Well, I saw the preview that you did in the all hands meeting and I got to play around with the organization stuff as well. And like, it's a pretty slick interface. So that's not rolled out yet, is it?
It is actually. Yeah. So
it is
we can
rolled out already.
Pull out production and look at it. Yeah. We are in the business of shipping right now, so we're wrapping some things up for the end of the year.
Very nice. Hey, just a quick aside, a meta. So I just replied to a comment and replied as Goliath. Am I supposed to be replying as me, or
Yeah, I think
is
you
that how
can
that
reply
works?
as Goliath. That
All
sounds
right.
good
Well,
to me.
Timon, that was me saying hi. I'm sure Dan would say hi though as well.
Oh, absolutely. You can speak. You can always speak on my behalf, Mike. Actually, yeah, I actually would trust you to speak on my behalf. So, but no, I think, yeah, I don't know if we can even chat as our. I think we'd have to like go on YouTube to respond as ourselves. So, anyway, um, cool. Is there? You've also been working on hardware in the loop stuff a little bit, as well.
Yeah. Yeah, what a crazy many-headed beast the hardware and loop stuff is. Like, first of all, it's getting to be super stable now, which is awesome. But like, a I hate to say this, but like I've had the hardware and the loop runner sitting just like on this table next to me with like USB cables going out and like all the boards is not really attached to anything. And I just told Sam, I'm like, during holiday hours, one of my projects is going to be like to mount this stuff so I can like get it out of here. So it's not just sitting next to me, put it down like next to my router in the basement or something.
Hmm.
And yesterday I needed to move it and I smelled burnt electronics. And I'm like, oh no. And I actually blew a hole in my ESP32S3 dev kit C. Uh,
Oh,
I'm
darn.
sad
Okay.
about that. Actually, I'm not sure I did. I think that might have been on the outside. I thought it was the Scilabs chip, the USB chip that's on it. Does it have a Scilabs chip? Now I'm double questioning myself. I think it is a Scilabs chip that's on there. But yeah, so all of a sudden, I'm unable to erase the flash or talk to the flash or anything on this device, which was really sad. And all of our tests started failing. But I plugged another one in, and the new one's going to have a different serial address because they enumerate based on, I don't know, some serial number that's in the USB chip. And I was able to just run one workflow that queries for what boards are attached, and then that creates it opens a pull request on our private self-hosted runners repo, and you can go in and look, and sure enough, just the serial number and the port changed on it, and I committed that and re-enabled this device on the runner, and immediately the tests that were waiting for it started up and completed. So I was like, huzzah! Like, because the whole point of it is all someone should have to do locally is like replug a board, and everything else should start working. And I guess the other thing that we're working on this week is we're trying to scale up the like parallelism. So Sam went and made those tests so that if we test, we must be up to like 6 different boards that we're testing each time a test is run. There's more total boards than that, but I think that the largest number on one test is like 6 boards. Um, if we only have like 4 runners, then you're still kind of like waiting on those. So like trying to get more runners and more boards out to those so that the parallel tests are taking no longer than the longest single test.
Mhm.
And I think we're getting there.
Yeah, that is awesome. It's been really cool to see, and I still think we need to put together a blog post about like the the sequence of actions that run to do exactly what you're saying when you plug in a new board. Um, I've seen lots of creative uses of GitHub Actions, but the way that it like auto provisions new boards and then they're immediately available for use in other repositories that like don't even know about that system. So like for example, I'm sure folks can see, in the firmware SDK, runners being targeted, but there's magic that's happening in a private repository that's handling provisioning those and stuff. So uh, that is I haven't seen anything like that before. I don't actually. I mean, I assume other folks are using GitHub Actions for hardware in the loop testing, but I don't think there's a lot of content, at least based on the fact that you all have like the first results that come up if you search for it. So yeah, I think that would be a like almost like a reference architecture for how to do that. Would be
Yeah,
it would do well in the SEO, let's say. So
yeah, it's a tough one because it's like I see the improvements coming down the road, and so you're like, well, you should wait after, there's always one more improvement coming that you can wait for to do those sorts
mhm.
of things. But I think one of the things that I had an issue with this week is we added a new board type in, and then I named the credentials files wrong for it. And so we are still doing like, Matt, you put in a credential file as a secret with the name of the board as the secret name on there. And like, if you screw that up, or if you screw up putting the credentials in there. So I think, probably the next step for us is like, we're going to provision devices on the fly. So you don't need to have a Golioth device already on record for the board in order to run a test on it, because the workflow will just provision the board using the Golioth REST API. So I'm pretty excited for that. The only thing that I think is crucial is like, some of these devices are Wi-Fi, like the ESP32 devices. They need to connect to the router that's part of the self-hosted runner. So you need to know ahead of time the AP pre-shared key for that router in order to connect to Wi-Fi. And like passing those to the board, we're still passing those through like a secret for each individual board. And it should be like org level self-hosted runner, like the single board computer has that in. So like, I think, what are tests supposed to do, right? They're supposed to save you time. So like, you're supposed to find the errors or the regressions or the problems like a little bit earlier than you would have if you just like went along without doing any testing. And so I think we're trying to pick the things that are going to be the biggest force multiplier along the way and get those implemented first.
Yeah. No, I definitely think there's room for improvement. The fact though that you can actually just put the secret in GitHub though I think that's actually pretty incredible in itself. Like, I mean, that like you're connecting your device, an embedded device, to your Wi-Fi by running a GitHub action is like pretty neat in my opinion. So it would be cool to see how that continues to evolve. And I like that one of the parts I personally enjoyed about it is, we're using OCI images for basically creating these environments to be able to talk to it. And so it allows me to like get little glimpses into the work y'all are doing, just to come in on that little part of it. That's been a lot of fun to see that and also do some creative things with those images as well.
I totally forgot about that part. Like, there's been so much going on. It's crazy. So you and John did some really amazing base images for cloud side runners using whether Zephyr or NCS. And so I built upon that work, because you're starting with like minimal Debian, which is like a lot smaller than starting with the Ubuntu. So I actually built off that. And instead of installing the Zephyr toolchain, I just installed the NRF tools, NRF JProg tools, which is the command line tools for programming Nordic devices, and then ESP tool, which is for programming ESP devices. And then I got hit along the way because you need a few other things. Like, we're installing some custom Python packages, and if you don't have build essentials in there, then it won't be able to build the custom Python packages you're installing. But basically got to like a 1.4 gigabyte container, which is not bad, in order to get like a fresh Python environment every time you run a test on these runners, which is fantastic.
Yeah, absolutely. It's funny. 1.4 is definitely not bad for these images that are used for like embedded workflow running and stuff. But like in the rest of the world, it's like, that is humongous. So it is funny. But I think that's a good point. There's like the basically build images and then like the test run images. And the build images, we need all of the source, right, of the Zephyr and all the different modules we have in there. But what you were talking about there, you just you're pulling that binary down. Actually, the build action runs, right, and uploads the binary to GitHub Actions, and then the test run takes that, flashes on the device, and then runs tests against that, right?
Yeah, and so you need to be able to have whatever it is that writes to the USB device, and so that ends up being pretty sizable. I mean, I think the NRF JProg tools was like 600 megabytes, so that's a substantial part of it. But then you need to be able to run PyTest as well, because that's what we're basing our tests on. And we're installing some custom packages. Like, there's a Python implementation of the Golioth command line tools so that we can do some interaction that way. And so installing those, you need some of the build essential tool chains from Linux. I'm not sure exactly which ones, but I just was like, I'm just going to do build essential because that's what everyone does. That mostly fixed it. libusb, I got caught up on. I can't remember if there's anything else, but that all seems to be running really well. And I don't know what it like. I don't know about you, but whenever I run Python stuff locally, like I have a virtual environment for that project just because you get like a package pollution in that Python environment, but you can't really use virtual environments, or it's a little bit wonky to use them in the workflows. So it's nice to be able to just start from the clean container.
Yeah, yeah, absolutely. I am not a fan of Python, but I've had to I feel like I went a number of years without really interacting with it much because at least in like cloud infrastructure, I feel like it's not used too much just because Go has become so prevalent. Um but certainly getting back into the embedded world, there's so much use of it because of its ability to interface with C so easily. But it is the environment story and everything like that is no fun at all. That's the pain of, I feel like, using an interpreted language and not just having like static binaries, because in the Go world, we're just like, get the static binary for my platform and it works all the time, right? And so that's a pretty nice feeling.
I was pretty excited to see that the OCI images can build for multiple platforms, because
Mm.
we started with runners that were x86 and moved to some runners that were ARM86. And so you figured out how to just get the workflow to build both of those and make them available.
Yeah, and it definitely did not used to be that easy. I mean, there's a few different components of that. So before BuildX, it was like a real pain to try and do that. And you had to mess with a bunch of QMU stuff, and it was just no fun at all. And then the other part of that is when you push images, you push basically OCI images. You essentially have like your manifest, which it's a JSON document that enumerates the different layers of the image, which are just binary blobs, right? And so you have to upload those blobs and then you upload a manifest. Well, you need to do that same process for each architecture. And so it used to be that you'd have to basically tag separate like ARMs, let's say ARM64 and AMD64 is how they distinguish architectures. And you'd have to tag those as like, Goliath, Hill, Runner, whatever, dash ARM64 and dash AMD64. You'd upload those separately. And then you had to upload a manifest list, which basically said, hey, here's another JSON document that points to the other two JSON documents, then point to the layers. So that was all a separate process. But now with BuildX, it both handles setting up a BuildX runner, which is, essentially just using virtualization to cross compile and things like that. And doing that whole dance of uploading the different manifest lists. So for you, it looks like one tag, as opposed to like having to tag each image and then tag a manifest list that references the other tags. And it was all a mess in the before times.
So when Docker goes to check it out, then it must say, "Hey, I'm an ARM64 device," because I
Yep.
didn't have to specify that anywhere.
Yep. Absolutely.
That's nice.
Yeah, we so at my last role, when I was working on Crossplane, this open source project, we used OCI images for just like arbitrary text data. And so it was basically like YAML documents that we were just sticking in OCI images. And so like when Kubernetes pulls an image, right, the node that the container's workload is going to run on has an architecture, right? So ARM or AMD, typically. Well, there's more ARM servers now, but a lot of times AMD, right? So when it pulls, right, the container runtime says I'm going to pull the image that works for my platform and architecture. But we would, regardless of what node you're on, we needed to fetch the just the YAML out of it. So like it's not platform dependent at all, right? It's not a binary that's targeting specific machine instructions. And so we would always have to just like parse the manifest list and say, okay, what architecture is supported? Like we're fine with whichever one is there, like we don't actually care. But it was kind of a pain actually, because we couldn't just actually having the flexibility made it harder essentially to decide what to pull. And so, but yeah, that Docker will just handle that for you, or any other container runtime, which is nice. Cool. I was gonna look back. We put together a list of things to chat about, and I can't remember what they were. Uh, oh, we already talked about a number of them. Oh, another thing I was gonna talk to you about is just Zephyr drivers in general. Um, I was recently working on I don't know where it is. I might grab it in a second. But I have the I know you already know this, but I have the Pine 64 um, Pine Sill soldering iron, and it runs. Um, Actually, maybe I should share my screen here in a second. But it runs Iron OS, which is like this free RTOS based um, uh, firmware for soldering iron. So it supports the Pinesill V1 and V2, and then it supports the TS 100 or whatever that line is of soldering irons. And I wanted to basically run Zephyr on the soldering iron. I thought that'd be neat. Well, it turns out that the of course the board isn't supported on Zephyr, but neither is the chipset that it's using, which is from a company called Buffalo Lab. And so I've been working on basically like adding support for the SoC, then adding support for the board, and then learning about like the device tree and device tree bindings. And then the
you
board.
You really do like to start at like the atomic level and go up.
Right. I'm like, oh, what is it? I think the first Zephyr thing I did was write that blog post that was like, what are like, like the first basically 100 instructions that Zephyr executes when it runs. So yeah, that's definitely my strategy usually. But basically, so I wasn't super familiar on I was familiar with how device tree works, I guess, but the device tree bindings and how that like enables different drivers and things like that, or selects the I guess the implementation of the driver. I don't know if that's how a Zephyr developer would say it, but basically how it does that, I wasn't aware of it. So it's been fun to go through that. But the other aspect of that is that there's no drivers implemented for this chipset. So I really got myself in deep here. And there's no I don't have access to the UART on this device either. So if I want to do like Hello World, I have to do it on the display. So basically, I've gotten all the way down in this place where adding the I2C driver, having to add a hardware abstraction layer for the Buffalo Lab SDK, which then I use in the I2C driver, which then is used in the display driver. So just like the composing of drivers as well was something that I was not really thinking about. But yeah, so that's been my journey, and I was curious. I know you've done a lot of work with I2C and Zephyr, and what's kind of like your level of knowledge of the various drivers on Zephyr, and also one of the things we had chatted about, like maybe just looking at one and kind of talking about how it all fits together.
Yeah, I mean, we can certainly go through that. I haven't done like the SoC level stuff, and someone asked me that on our free Zephyr training. Maybe it was just last week. Wow, time passes. I think it was a week ago, last Wednesday. And my suggestion is just go and look at a chip. I mean, it can't be that much different than implementing a chip that's already in there. Is that kind of the approach that you took?
Yeah, absolutely. I used a actually, I don't know if I would recommend exactly what I did. It's because for different architectures, the organization is a little bit different. Especially RISC-V, I think probably because it's newer. It does a little bit different of organization where it takes whether it's a privileged or unprivileged architecture. And then from there, it like divides it into vendors, as opposed to like ARM, where you go straight from like, is this 32-bit or 64-bit ARM, and then you just go straight into the vendors. But there's also different like families, series, SoCs within like the SoC system. So I mean, I can also pull up and kind of show
and
what
I think my kind of like understanding of that too is like following that chain can be a little tough too, like how they all get connected together and pulled in. Certainly the driver stuff that I've done has been like higher up. So I'm doing like sensor drivers, not like UART to the chip drivers. So I don't know. Maybe there's dragons there. Who knows? I do know that I've looked at the device or the display driver and
Mhm.
trying to patch into that, and that is not totally straightforward. Or I think I was like, can I add LVGL support to this display? And I was like, ooh,
Mm.
there's a lot of work there.
Yeah, yeah. So one of the things I learned when looking at this is like almost all like OLED displays use the same controller. It's like the SSD something. Um,
1306.
yeah, yeah. I think there's like 3 in that line maybe, but they're all like pretty similar.
Yeah.
So I think that if you have a I squared C implementation for the SoC, then you probably don't have to implement the display driver, because
Yeah, I
it
mean,
just
I've
opts to go
certainly
for that.
abused that I squared C driver by like directly calling, uh, instead of using the I squared C abstraction, I'm actually calling the like I squared C read, I squared C write, I squared C
Mhm.
burst write, stuff like that. Like that's all fine, but it's still one layer above where you're working.
Yeah, yeah, for sure. Well, I can pull it up and kinda show you,
Yeah, let's do
if
it.
you're interested.
Yeah, let's
Um,
bumble around in the Zephyr tree. I'm all about it.
yeah. Alright, cool. Let me see if I can also, um so actually the full part of this story is, um, that well, here, let me actually pull it up, and then this will make more sense. Let's share screen, and let's get Slack out of here because that's a dangerous game to play. Um, all right.
Oh, you know what? I did not. I guess I'm not sharing my screen. I was going to say I did not turn off my notifications.
Oh, well, yeah, you're not sharing, so I think you're okay. Um, so a few different things here. Uh, One, I want to. There's not currently a guide. There's a guide for adding boards, as well as a very good Goliath blog post about it that will show up very prominently in Google if you search for it. But there's a guide for adding boards to Zephyr, but there isn't a guide for adding SOCs. And if you look at the board guide, actually, here I have it right here. If you look at the board guide, it kind of
I
yeah
also think
says make
if you want to zoom a little bit in on your screen, Stan, I think that'll help. Awesome,
yeah, is
thanks.
that better? Cool.
Yep, perfect.
Um, so yeah, it basically says like, is your SOC supported? If not, like that, it's basically the way it doesn't exactly say this, but it's kind of like you've got a lot of work to do. It's like make sure your SOC is supported. If it's not, then like ooh, that's tough, kind of thing. There
Yeah.
there is architecture porting guide. It's really not that bad, honestly.
Mhm.
I actually I was impressed going through it. But there isn't a guide for it. So part of my goal is in this is documenting all of it, and you can kind of see here, if I can also make this bigger, that I've been taking lots and lots of notes here as I go through everything,
Wow.
including
Yeah.
like
Great.
what issues you could run into and that sort of thing,
Mhm.
and why they may be happening. Because a lot of it has to do with just like the CMake modules that that you're going to be using with Zephyr are going to look in specific directories based on your various K config symbols and things like that. So part of my goal here is to put that together so the next person can come along and add an SOC easily. And my other goal is getting a talk submitted and hopefully accepted so I can go to Embedded Open Source Summit with y'all. But I started out with the actually not using the PineSill. I was using this 0x64, which I have a couple of, which is a single board computer. So it can run Linux on it, but it has 3 different CPUs on it. So there's this, sorry, keep reminding me to make things big if I forget.
Okay.
Um, but it has a 64-bit RISC-V CPU. And so this is pretty capable, right? It can run Linux, has memory management, etc. And so not typically, what you're going to run Zephyr on. Although I think there are some uh, CPUs like this that do
Yeah, I was
run
going to say
Zephyr.
I've run Zephyr on an RT1062, which is a beefy 600 megahertz monster.
Yeah, yeah. So you certainly can. But what I was going to try to do is target just the this kind of like embedded CPU. Um, and there's these three CPUs. They call them D0, M0, and LP. So they have a low power one as well. But this M0 one, I was just going to try to run Zephyr on that. And I was going through that, and one of the things I noticed, and I know there's some work. I think this is kind of like top of mind for 2024 for Zephyr, but to support running or support heterogeneous architectures, right? Where you have multiple cores that are either different architectures, and I know some of the Nordic folks are interested in that because they're starting to use RISC-V supporting cores on their boards. But anyway, it's not well supported right now, so I kind of pivoted back to just looking at the Pine Cell, which is simpler. And at some point here, I say that I'm going to do that. But anyway, they're all Buffalo Lab chips. So that's kind of how I ended up here.
Yeah, my perception is that Zephyr really wants to get as many vendors supporting the SoC as they can, even if they don't like go deeper into the project than that, just because, if you port this one chip, then it's just this one chip. And then if a new one comes out, we need you to port it again. I think it's more likely you're going to have like long-term support from the vendors. Also, the vendors have at their fingertips all of the register information that you could ever want until the cows come home.
Right.
But I also, it's my perception that some chips, perhaps like ST chips, have community implementation. And so it is like, if you want to do the work, everyone's thankful for it.
Yeah, absolutely. And I certainly do want to do the work, which is maybe not best for my social life, but it is a lot of fun. So anyway,
so your Hello World for embedded though should not be writing Hello World on a screen. It should be twiddling a GPIO.
I agree. Although, as I said before, I don't have any way to like talk to this chip. So I don't have so if I was using the 0x64, I certainly do. But I went with the Pine Cell because it ended up being easier to support the SoC. And so actually here I can show you the what I really need that's going to make this way easier is the, let's see, Pine Cell V2. And in the wiki, let's see if I can. So there's a breakout board. So I did order one of these, which is going to make this way easier because I can get access to the UART on it because it breaks it out over USB. But I don't have this right now.
Oh, interesting. Yeah.
Yeah. So and actually, this is another fun thing that I'm hopefully going to write a blog post about. But I don't have this adapter either. But I'm going to use a Pico for it, Raspberry Pi Pico. You can actually, they have some firmware where you can have it act as a USB to UART kind of access there. So that should be fun as well. But so since I can't just do the like print hello world kind of situation. That's why I got into the whole place of trying to write to the display.
How do you flash the device?
It has you can flash it over USB-C. And there's this, they have a custom kind of like IDE sort of situation for doing it. But then Pine64 has this in-system programming tool, which is what I've been using. And I actually just pulled it out. You can use it as a library as well. In fact, I think one of these here, I closed the tab, but I was just using it to like query what's on the device right now. So they've reverse engineered basically the protocol that you can talk to for, I assume it's, the bootloader on the SoC.
Okay. So when you get that breakout, do you think that you can get GPIO on that board as well?
I am not sure.
Can you open the case for it, or is it not a thing you like to take apart?
I can open the case. I haven't done it yet though. Okay. It is the only soldering iron I have right now, so I've been a little hesitant to. I do have another soldering iron coming, but
So you're building the car while it's barreling down the highway, is what
yeah,
you're telling
exactly.
me.
I was talking to Chris about this, and he was saying, well, you could just like attach some wires to the pins, and you can just solder them on there. And I was like, well, that's going to be pretty hard because I don't know how I'm going to solder my soldering iron. So there's a variety of things. I think the ultimate outcome here is that I'll get the breakout board before I get the writing to the display working, uh,
Mhm.
and then I'll punt on writing to the display to just get the SoC and board support in, and get the what do they call the Hello World?
I'm just
The
wondering what all those other pins are on it.
Oh, they
So I
get
see
broken
the
out.
RX, TX, and ground. That makes sense. So you got your serial connection there, but then there's like, you know, 24 other pins.
Yeah, let me see. I think that there's more information on this somewhere. Um, well, they have the schematics.
If they show you if there's a backlight, you can
Mhm.
just you can blink the backlight.
Ooh, that is a good idea.
Like
I
I'm
haven't
always
looked
telling
at this in a
Chris, I'm
bit.
like, Chris, just put one LED connected between a GPIO and ground for me, so I can at least know if the thing is running my code.
Yeah, yeah, that's fair. So you have a UART. It looks like you can break out a number of things here. You can do JTAG debugging.
Ooh.
So yeah, it gets significantly. There's a lot of different things I can do once I have this. It is taking a very long time to ship. I ordered. Well, depends on what you're used to, I guess, whether it's a long time or not. It is a frustrating long time for me right now because this has been like 4 weeks now. But anywho, what I would like
Yeah.
to get working is the where are my samples? There we go. Just the hello world. Just get this kind of thing going would be really nice.
Yeah, I think you're going to want that. You're going to want a debugger on it, some type of SWD or JTAG, just because before until you get like UART output, it's caveman, it's rocks and
Right,
sticks.
right, for sure. Um, Cool. Well, I can kind of show what I've done so far for the SOC. So for folks who let me make this bigger. For folks who haven't been in Zephyr Codebase before, you basically have your SOC layer. So we have organized by architecture here, and then up in your boards, you're also organized by architecture, and then these will target different SOCs. But the board is the entire board and all the peripherals that are available. And then the SOC is just the cores that are on there. So this is a RISC-V core. So this is what I was kind of mentioning before. They have the RISC-V privileged and then the unprivileged ones as well, which they're by vendor. This is actually an FPGA soft core here, but you
I
can see
actually
this
don't know the
is
difference between privileged and unprivileged.
so the privileged specification. There's a unprivileged specification and privileged specification, um, and so basically, privilege would be like you can access all the memory and that sort of things, and then unprivileged would be like you have a user space. Um, so that's basically the difference. You don't have to implement both levels though.
Okay.
I forget. There's machine level. We could actually pull up a. Let me pull up a list here. I wrote a blog post about this one point, but I am rusty. So yeah, user supervisor and machine. So machine would be like where you boot to. Supervisor would be like, let's think of like a PC or something like that. Supervisor is where your operating system is running, and then user space would be where your applications are running, and then you're doing system calls across them um, to get between them. So in privileged, we have the Buffalo Lab BL7 is what I added. So this is the 7 series of the Buffalo Lab. Let's see if they have their site on here. Buffalo Lab. So they have a few different product lines. Let me see if I can pull up. So yeah, the kind of like 600 level, 700, and then 800 is what the. Okay, wait. Here's 600. This is 700. So I think the Pine Sill has the 706 on it, and then the 0x64 has the 800 series. I don't know where that is right now. Looks like I can't see it right now, but the 706, I believe, is what the Pine Sill has. We could double check that. Actually, BL7, yeah, BL706 chip. So that's what I am adding support for. And so in here, we have the SoC. So we're saying this is the BL7X line here. And then we're saying essentially what are the RISC-V extensions that are supported. So it's 32-bit base integer instruction set, also with the multiplication, atomics, and compressed instructions, which basically just determines, when we're compiling, these get passed to the compiler. So it knows, what instructions it can generate and which ones it can't. And then in this case, let's see what else we have. Just the series and the SoC that's supported. And I think that's pretty much the only interesting stuff. I'm not sure if this is actually going to work because I haven't got it successfully compiling yet. But there's a common linker script that's used across it, but I'm guessing that I'm going to have to make some modifications there. But essentially anything that you need to be specific to the SoC goes in this directory. So if you went and looked at, let's actually look at the ESP32C3 here, you can see that it's got, quite a bit more stuff in here that it needs for, setting up bootloader kind of things and various other stuff that it needs. So that was the first area. And then in the boards, also under RISC-V, I added the Pine Sill and the definition for it, and saying, it depends on that SoC. And I'm trying to think if there's anything else interesting in here right now.
So when you select the console as UART0,
Mhm.
then you must have a device tree, maybe a DTSA file with the UART0 defined in it.
Yes. So, well, I don't right now, it looks like. But in theory, yes. I haven't completed it yet.
And then how does the driver get pulled in though? Because it must, when it sees that in the overlay file, it must then automatically build in the UART driver.
Yes. So that's over here for the SoC. You can, so here's the UART0. So it's basically saying, what memory address is it accessible at, and what size is the range of memory. And then this is where it's saying this is what it's compatible
there's the
with.
binding. Okay. Yeah.
Yeah, exactly. So that's the part that was kind of new to me, is like understanding how the binding worked. And then
so then there's a DTS bindings directory is at the root of Zephyr. Is that where it comes from?
Yeah, DTS/bindings. Mm-hmm.
And what's inside of there? Can we just take a look at that?
Yeah, so I think for any of the drivers, so like let's look at, well, I guess it'd be serial, right? Yeah, serial. You'll go in here, and then I add this Buffalo Lab BLUART, and it's basically like config for the UART or the serial driver that is not functional, but that I put the scaffolding in place for, so we could actually pull that out here. Serial. somewhere in here. Pretty sure I added
Yeah, it is
something.
just, it's like all over the place with these files. I mean,
Yeah.
like Chris and I were just talking about this because I'm going to work on a blog post called Zephyr. Well, actually, because there was that Reddit thread where people are like trashing on Zephyr. And the thing is, like, any like substantially advanced tool is going to be complex. Like, there's
Right.
just really no way around that. And so, like, Zephyr aims to be an engineering tool that doesn't prevent you from doing what you want to do. Like, I don't want to say no guardrails, but the guardrails are definitely meant to stay out of your way.
Right.
And so, like, this is like, look at how many chips are supported in this one tree. It's crazy, right?
Right.
And I guess the flip side of that coin is it's all over the place.
Right. Right. Yeah. I think, at least from this perspective of, I don't know what I'd call what I'm trying to do here. Like, I guess like the, like Zephyr from scratch sort of, kind
Yeah.
of thing. I mean, the kernel isn't, I'm taking the whole kernel, right? So I'm not doing that much from scratch, but like going from, an SOC to like Hello World, uh, I've been really just like appreciative of a predefined structure being here for me to like fit things into. Like, it's
Yeah.
kind of hard to overstate how much decision fatigue it's removing for me just like copying things. Um, so anyway, it is definitely really nice to say like, all right, I've basically been going through, and that's one of the things I've been keeping a log of. Um, you'll see kind of like farther down here is like, okay, I added the SOC and then tried to compile. What error did it give me? What was I running into? And just kind of like stepping through that is way easier than going from, totally zero. Um, in some respects. And once you get it to adhere to the Zephyr structure, then you can do a lot of things really quickly. Now, you do have to have like drivers and things like that, right? So it's not just all for free once you add the SOC and board, but there is a lot of just like, hey, once you kind of do the legwork, you start to get like a bunch of wins really quickly. But getting over that initial hump, I think, is the kind of stage I'm in right now. But it's been fun.
As you try to do the builds, are you looking at files in the build directory and like comparing them to like a device that builds correctly and seeing like, well, what parts am I missing?
Yeah, so I think I'll show you kind of like the most recent one that I was running to. Or actually, let me first start with one that I guess I solved to some degree. Um, so here's me understanding what address cells and size cells mean and that sort of thing. Um, oh, I will say another thing that's been helpful with this is being able to look at the Iron OS port for
Right.
PineCell V2. It is free RTOS, but that's actually been useful. It's just like understanding what I mean. Obviously, the schematic has what pins are what as well, but it is a little easier to like go in and look at like, okay, what pins are we using for I squared C? So a lot of that's been pretty easy as well. But I was trying to find where I was basically had the wrong structure for the CMake SOC. Well, I can't find it, but I can kind of show you, I guess, where I was at. And actually, this was pretty illustrative for me because, as infamously, one might say, Zephyr uses a lot of its like custom CMake commands. And so going in and actually just looking at all of these different components of the Zephyr module has been pretty interesting to me. And one that I was running into was, let's see, yeah, this SOC CMake. Let me close this. So looking at this and kind of like finding out how it targets the different directories, I think was super interesting. If you build and hit an error, you can look at exactly what we're trying to do here. So basically, we're calling GCC with these defines here and what we're including and everything like that. So one of the things I was doing early on was building the hello world for a chip that I knew worked. One of the Sci5 RISC-V ones, and literally just copying this and diffing what I was getting here and figuring out, like what am I not including? That's, actually how I kind of like stumbled into like where the drivers are and that sort of thing. So that's been helpful. But one of the things I was running into is I had and you'll see I insert these message stuff around here to see how it's processing things all over the place.
That's my go-to as well.
Yeah. It's one of those things where I'm like, it feels like, don't do printf debugging, but I'm like, well, it's kind of like the most effective pattern here.
How else do you debug the CMake chain? I mean, really, like.
Yeah, I have not found a great strategy for doing so. Although I did post something about this on some social platform. There's too many these days. And someone responded and told me that Visual Studio has a CMake debugger built into it. To which I said, that's very sad. But also, I mean,
except
great.
If Visual Studio has the debugger, it might be running on a language server, which NVIM supports. So
I'm sure there is a language server for CMake. I've yet to find something there isn't a language server for. But yeah, so basically I had because RISC-V has the kind of like RISC-V privilege level. At first, I was trying to kind of model after the Nordic directory because they had this kind of like NRF51, NRF52, etc. And the Buffalo Labs also had the, like BL7, BL6, BL8. So I was kind of trying to model after this, but it's, you'll see I'm in SoC, ARM, Nordic, NRF, whereas in the RISC-V one, I'm in RISC-V, SoC RISC-V, RISC-V privilege, and then in the vendor. And so basically I had like an extra layer, and so it was unable to identify it. So I basically compared that.
Yeah. Okay.
So I had the, let's see where it, so it takes SoC series and it was doing SoC path, and the SoC family is RISC-V privileged, and the SoC series is the Buffalo Lab BL7. So what I had before was Buffalo Lab, and then inside of Buffalo Lab, I had like BL7, BL6, and BL8.
Okay.
And so what it was doing was saying SoC family is RISC-V privilege, SoC series, I think was just BL7. So it's basically looking for BL7 here. So anyway, that's an example of where I compiled with one that worked and compiled with one that didn't and compared the paths and then figured out this was happening. But right now, for example, I'm stuck on the why this is not, I stuck an error in there. But basically, this is not defined for, it's coming from common. Yeah, you can see I stuck the error in here. But this exception mask here is, it's saying that it's not defined for some reason. So it's somehow not including the common directory in here. But essentially, I've been diffing that with the other one and seeing how it works. So yeah, it's been a journey. I've been trying to find time, but it is not my main priority. So
it's not a great time of year to find time for stuff, though. This is kind of like the wind down time of year, right? Do you?
Well, I feel like it's it's in some ways a bad time, in some ways like the best time.
Yeah,
because
maybe.
like,
Do you have like some cool projects that aren't the Pine Sill thing for the holiday hours time, or is it all steam ahead on Zephyr?
Well, so I don't feel like this is really, I mean, it's related to my day job. So I guess this is a side thing. So this is not what
it isn't. I mean, we do an awful lot of Zephyr, and if you are the domain expert in SoC level Zephyr stuff, that helps the company.
Yeah, that's true. That's true. I would like to get this to a place where it can actually be upstreamed. and then be able to kind of maintain the Buffalo Lab port. But part of that has been taking the Buffalo Lab SDK, which we saw there briefly, and converting that into a Zephyr HAL. So there's a number of steps where, one, I had to get the Zephyr or the Buffalo Lab HAL upstreamed, not into Zephyr, but into the Zephyr org on GitHub, and then add that as one of the modules in the list. And so there's a number of steps, but slowly working towards it. I do have some ideas for holiday hours though, but this is after hours holiday hours.
Well, let's hear them. What do you got? What do you got planned?
Well, some of them I'm not sure if I can say on
Oh,
on the
okay.
stream
All
right
right.
now. But a couple of things related to getting more data to our customers about um, uh, the data that their devices are sending. So the volume and frequency. Obviously, we have customers are able to access all of the data that their devices are sending, and we send it along. But getting high level metrics on that, and being able to see, like how much data has my whole fleet sent this month or something like that. Those have been top of mind for me for a variety of reasons. So that's the
I
teaser.
weren't. I once heard an anecdote that if you show people how much it costs to turn their thermostat up by 1 degree, that everyone would turn their thermostat up because they'll associate that with being a smaller cost, but then it amortizes over a long period of time and it ends up costing them a lot. But like the
Yeah,
psychology of it is if you see, oh, I'm only using this much data right now, I can use all the data I want. So
yeah.
it is good to get that long haul calculation so you can see what the true cost of those bits and bytes is.
Yeah, yeah, absolutely. And also like from a I feel like pricing always feels like a weird thing to talk about. But like, the from my perspective, working in a company, uh pricing is like a really important reflection of like our values as a company. And so in order for us to price products in a way that allows us to operate as a business, but also allows our customers to be able to enables them to build the things that they need to. Right, we need to have a good understanding of how what our costs look like. And so we have some ways to do that already, but continuing to get more information on that, in my mind, enables us to enable more folks to build connected devices. And so that's yeah, I guess like trying to kind of take like a aligned with our mission approach to pricing is something that is part of that effort as well.
Yeah, I mean, also like the point of IoT is the ability to scale, right? So like
Right.
you want to know, like, okay, how much data can I squeeze out of this one device that could turn into 1,000 or 10,000 very quickly?
Yeah. Yeah, that's a great point, and I think something that goes along with that it's going to be a priority for next year, or has been a priority, but there will be some launches next year that manifest that priority in our product. Is also aligning incentives with customers being able to optimize, right, and reduce the amount of data while still getting the same functionality. Um, that's another area where I really like aligning our cost structure with our customers' goals and saying, hey, like we enable you to send the least amount of data as possible that's still useful, right? And kind of optimize on that front end and building features and products that support that. Uh, that's fun to me, I feel like.
Yeah, I'm with you on that for sure.
Yeah. So do you have some hack day or not hack
Um,
day, holiday hour
the
ideas?
holiday hours, yeah, there's a bunch of stuff. I mean, mounting my runner hardware onto something is top of mind because of my fried board last night. I think, so we were at Embedded World and we met with some of our friends over at Espressif at their booth, and
Mhm.
they had this ESP box. Have you seen this thing? It's
No, I
like
don't think
a
so.
it's like an almost a consumer. I'd like have one somewhere in a set of drawers back there. But it's like basically consumer electronics. It's got there's a couple different models. Some of them are touchscreen. I got one that's not touchscreen. It's just 3 buttons on the front, but it's got an ESP controller inside and a battery. It has like some quick connectors. You can connect sensors. I want to say it's got maybe an accelerometer on it. So you might be able to do like tap sensitive and touch.
Mhm.
And I was just really impressed by, the responsiveness. And it's a good little, like, you can buy it and put some code on it and connect it to the network, which is pretty awesome. And so that was March, and I ordered one while I was still in Germany, and I
Yeah.
have not opened the box yet. So
Oh, that sounds interesting.
I want to open it up. The other thing is we have support for ESP-IDF, and I just have done almost nothing with it for like 6 months. So
Yeah.
it'd be nice to kind of get some skills back on that. So I think I'm going to try and bring that up on Goliath and see if we can do some shenanigans with it. I mean, you can put memes on an LCD screen, so that
Yeah.
would be awful fun. The other thing is like $32 or something, so it's kind of like a no-brainer. If it runs Goliath, it's a good way to do demos for people.
Yeah. No, that would be really cool. Another area that I'm interested in is I know we've used Grafana for visualizations, and for the reference designs, you all put together some like really cool stuff. But thinking about maybe some like minimal kind of like charting stuff for if someone wanted to use Goliath, and like have a public page. Obviously, right, you could do that with Grafana, but if we had like a little more built in, I feel like that would be something that was interesting, especially for hobbyists, to be able to say like, maybe even like a password protected page, something simple, that they could like put up and share or something like that. Some of those are also top of mind for hack day hours for me.
Oh, that's
Maybe
very cool.
even one related to I think we've chatted about maybe before on this live stream, the wanting to do like more run tracking stuff. So like the GPS example that you have the reference design dashboard for, doing something related to that is that would be cool as well, but we'll see. Yeah. Well, cool. Well, is there anything else going on with you today, Mike?
I don't think so, man, but it's been fun hanging out. It's a good way to wind down the week with a little bit of shenanigans.
Yeah, absolutely. I absolutely love these, so I've been appreciating y'all being willing to jump on and stumble around through things with me.
Likewise, yeah, man. So I don't know if I'll see you on the next one, but if not, happy holidays. See you next year.
Yeah, same to you. I'm sure Mike and I will see each other in Slack and more meetings.
Yeah,
So don't worry, everyone. Mike
we'll
isn't
still be
isn't
working.
leaving me. Yeah, we're still we are still going to work. It turns out. But yeah, I don't know if we'll have a stream. I guess next week will be close to Christmas. I don't know how dates work, but we'll be getting close to Christmas, so we'll see if we have a stream. I'll also be in a different city. So, but anyway, great to hang out, Mike. Yeah. And have a great weekend.
All right. Bye, everyone.
See you, folks.